Okay, so from the previous lesson, we have we have seen how to transform. Okay, this is the original one, the dimensional form. We use the new variable. We able to transform it in the form of dimensionless variable, dimensionless form. Okay, now I would like to discuss about the solving part, especially this equation when we have a model involving velocity. As you can see, I will take the dimensional form, the same with dimensionless form. Actually, you will see here, you see rho multiply with rho, you will have the non-linear term inside this derivative, rho square. The same with dimensionless form, here you will have u square term. Okay, it is non-linear. Okay, so for this kind of problem, I will refer to the dimensional form. Okay, for this kind of problem, in order to proceed with the characteristic method, okay, this still remain, the rho derivative still remains, but this part, okay, you have to change. Okay, here if I write it back, I rearrange, modify this Vmax, I can take it outside because it is a constant. So we have Vmax, then del x, rho multiply 1 minus rho over rho max. Okay, so I can differentiate, okay, one by one inside here. So we'll have V max del, you can use what we call the product rule differentiation, or you can expand first. Okay, if I expand first, it will looks like this. We will have a rho minus rho square over rho max. Okay, so if we have this form, we cannot proceed with characteristic method. Let me show how we can transform it before we use characteristic method. Okay, next we can differentiate. Okay, differentiate rho become d rho dx. Next, differentiate rho square over rho max. Rho max is a constant, so we will have 1 over rho max. Differentiate rho square with respect to x becomes 2 rho d rho dx. Okay, so now I can rearrange this. I will factorize, I will combine to have del root del x in one single term. Okay, we will have V max. Okay, then we have here del root del x multiply with 1. Here del root del x multiply with minus 2 rho over rho max. Multiply del root del x. Okay, so we will have this form finally. Okay, so now we can substitute back into this equation. So if I substitute into that equation, okay, so now the equation, this equation becomes del rho del t remains. Okay, wait. Okay, del rho del t remains. So we still have del rho del t. And then the second term, after we modify, here we have this term. So V max multiply 1 minus 2 rho over rho max. Del rho del x, the right hand side equal to 0. So next we able to proceed with the characteristic method, in which here the equation is rho x and t. Remember the step-by-step for the characteristic method. First is we write it as ODE, dx dt. And we have to write the ODE for del rho del t. Then proceed solving the equation. Okay, so del x dt taking this term, right? And then del rho del t taking the right hand side term. Okay, so you can do the same way for the dimensionless form of equation. Okay, if we wish to solve it using the characteristic method, because here we have u square term. Okay, you have to modify the term first like this. Okay, until we get the form. Okay, like this one, we have del, for that dimensionless form, it should be del u del x here multiply with a term. Here should be del u del t.